5.3 Algebra with Matrices. What kind of operations can be performed with matrices? Properties of addition and scalar multiplication of matrices. Let A, B, and C be m by n matrices, and let C and D be scalars. The following properties of addition and scalar multiplication apply to matrices whose dimensions are all the same. If the following matrices are equal, find A, B, C, and D. A is the entry in the first row and first column. B is the entry in the first row, second column. C is the entry in the second row, first column, and D is the entry in the second row, second column. Given matrices A, B, C, and D, carry out each indicated operation, or explain why it cannot be performed. Let's begin by determining the dimensions of each matrix. Dimensions of matrices are always row by column. A is 3 by 2 because it has 3 rows and 2 columns. B is 3 by 2 because it has 3 rows, 2 columns. C and D have dimensions 2 by 3 because they have 2 rows, 3 columns. That means we can add and subtract A and B since they have the same dimensions, and C and D since they have the same dimensions. And our resulting matrix will have the same dimensions. So A plus B means we will have a resulting matrix with dimensions 3 by 2. To add A and B, we add the corresponding entries. For the first row, first column, we add the first row, first column number of A to B, so 2 plus 1. For the first row, second column, we add -3 and 0. Continue adding each corresponding entry. Then simplify, and here's your answer. For C minus D, we'll subtract each corresponding entry. So the first entry in the first row, first column will be the subtraction of the entries in the first row, first column for C and D, 7 minus 6. Continue. Now simplify, and you have your resulting matrix with dimensions 2 by 3. For part C, C plus A, because C and A do not have the same dimensions, we cannot add them. Therefore, C plus A is undefined because they do not have the same dimensions. For part D, 5 times A means to multiply 5 times every entry in the matrix of A. And here is your resulting matrix. For number 3, solve the matrix equation 2x minus a equals b for the unknown matrix x, where a is 2, 3, -5, 1, and b is 4, -1, 1, 3. First, solve the equation for x. Add a on both sides, and then divide by 2 or multiply by 1/2. So x is equal to 1/2 times the sum of a and b. Let's add the matrices a and b. Because they have the same dimensions, 2 by 2, it is possible to add them. Add each corresponding entry and simplify. Then multiply each entry by 1/2 to get the value of x. X is the matrix 3, 1, -2, 2. Multiplication of matrices. Matrix multiplication is associative and distributive, but not commutative. A times B is not the same as B times A. Matrix multiplication A times B can only be performed when the number of columns in matrix A is equal to the number of rows in matrix B. If A has dimensions m by n and B has dimensions n by k, then the resulting matrix A times B has dimensions m by k. If A1, A2, A3, so on is a row of matrix A, and if B1, B2, so on is a column of matrix B, then their inner product is the number A1 times B1 plus A2 times B2 plus so on. For example, taking the inner product of the row 2, -1, 0, 4 and the column 5, 4, -3, 1/2 gives 2 times 5 plus -1 times 4 plus 0 times -3 plus 4 times 1/2. So the inner product is 8. That will be the entry in the new matrix. Number 4, find A times B. First, let's establish that this product is possible by determining the dimensions of A and B. The dimensions of A are 2 by 2, and the dimensions of B are 2 by 3. If the columns of A match the rows of B, then it's possible to find the product. And the answer matrix has the dimensions 2 by 3, the number of rows in A by the number of columns in B. Now let's find the inner products. For the entry in the first row, first column, we'll find the inner product of the first row of A and the first column of B. That would be 1 times -1 plus 3 times 0. For the entry in the first row, second column, we'll find the inner product of the first row of A and the second column of B. So 1 times 5 plus 3 times 4. For the third entry in the first row, we'll find the inner product of the first row of A and the third column of B, 1 times 2 plus 3 times 7. For the entry in the second row and first column, we will find the inner product of the second row of A and the first column of B, -1 times -1 plus 0 times 0. For the entry in the second row and second column, we will find the inner product of the second row of A and the second column of B, so -1 times 5 plus 0 times 4. And for the entry in the second row and third column, we'll find the inner product of the second row of A and the third column of B, so -1 times 2 plus 0 times 7. Simplify each of these inner products to find the entries of the resulting answer matrix. And you get -1, 17, 23, 1, -5, -2. For number 5, calculate AB and BA. Notice that A and B are square matrices with the exact same dimensions. It is possible to find the product of all square matrices when they have the same dimensions, and the resulting matrix will also have the same dimensions. This is because the number of columns in matrix A is equal to the number of rows in matrix B, making your resulting matrix the number of rows in matrix A by the number of columns in matrix B. Find the inner products for A times B and simplify to get A times B. Remember, the multiplication of an inner product is always row by column, the same way we label dimensions, row by column. And your result for A times B is 68, 3, -3, -6. B times A is also a possible product because the columns of B are equal to the rows in A. Therefore, the resulting matrix will be 2 by 2. Find those inner products and then press play to check. So B times A is -1, 7, 48, 63. This is why matrix multiplication is not commutative. For number 6, write a linear system as a matrix equation. Multiply to show the equivalent linear system for the matrix equation below. Use inner products to multiply row by column. The first row times the column matrix XYZ would be 1 times X minus 1 times Y plus 3 times Z. And that would equal the result in the entry in the first row, so 4. For the second equation, multiply the second row by XYZ to get X plus 2Y minus 2Z equal to the result entry in the second row, 10. And for the final equation, multiply the third row by the column matrix XYZ, resulting in the inner product of 3X minus Y plus 5Z, and that is equal to 14.